We were learning this EIGRP protocol for a couple of days, and we learned that there is an algorithm called dual diffusing update algorithm, which is responsible to provide a low-cost path for every
Yeah.
destination. Not only just low cost, also a loop-free path
Yes.
for every destination. Now, to understand how it can provide a loop-free, low-cost path, we need to understand some terminologies. What is AD? Usually, we use AD for administrative distance.
Yes.
But here, we are not talking about administrative distance. We are talking about the algorithm called dual. In dual, there is an AD. In dual algorithm, there is an AD, which is called as advertised distance.
Okay.
Advertised distance. AD is advertised distance. What it is? Advertised distance is the metric that is advertised by your next router for the next router to reach the destination. I repeat again. This is router A. And you got router B. And router B is connected to many routers, and there is one router X which is connected to a network 1.1.1.1. Now, in EIGRP, it's a distance vector protocol, I told you. It's a advanced distance vector protocol.
Yeah.
So what EIGRP does is it advertises the routing table to router A. In the routing table, the network called 1.1.1.1 is advertised.
Yes.
That is why we call it as advertise. Now, what is the distance? Distance is the metric. For example, from router B to router X. If the metric is 18,000, okay, that is what advertised distance for router A. See, for router B, 18,000 is the total metric. For router B, that is the metric to reach 1.1.1.1. But when router B advertises this metric to A, is this a metric for A? No. It is the cost. Now you read this line, cost between the next hop router. What is the next hop router in our case?
Router A.
Oh, no. For router A, advertised distance is coming. Advertisement is coming. Now for router A, who is the next hop router?
Router B.
Now you see, advertised distance is the cost between router B and the 1.1.1.1. Isn't it?
Yes.
Yeah. So advertised distance is the metric for the next hop router to reach the destination. Am I right?
Yes.
Advertised distance is the metric for my next hop router to reach the destination. That is advertised. Can you please tell in your own word what is advertised distance?
So advertised distance for a router or for a destination, it is a cost between the next hop router plus the destination.
Don't say what is written there. Please see what is written there is something miscommunicating. That is why I'm telling you in my own word. Advertised distance is the metric of router B to reach the destination. Advertised distance is the metric of next hop router to reach the destination. To reach the
So I have one doubt there. So for example, for in the perspective for router A to reach destination RX So it is called advertised distance, right?
Come again, sir.
From router A to reach router X, it is the advertised distance, right?
No. Sorry.
Okay.
Router A is getting advertisement saying
Router X is this much distance from router B. Am I right?
router A is getting an advertisement from router B saying, for me, it is 18,000.
Got it.
See, in RIP, that is not the case. In RIP, it will say, for me, 18,000, for you, 19,000, something like that.
Correct. +1, yeah.
But EIGRP is advanced. EIGRP is not worried about what is your metric. EIGRP simply says, for me, it is this much. You decide what is for you. I am giving what is mine.
Yes.
Okay, so how much? Sorry. So router A is not receiving its metric from B. Router A is receiving B's metric, which is
Yes.
what called as advertised distance. You see the name why they call it as advertised distance, because it is coming as an advertisement. Okay. Now what is the feasible distance mean? FD means what? Feasible. See, here is the spelling. Feasible distance. Feasible. Feasible. Feasible distance. What is the feasible distance? Let's say here it is 3,000. What is 3,000? It is the metric between A and B. Now, what is feasible distance? Feasible distance is the cost from the local router to the advertised router,
Got it.
which is 3,000 plus 18,000. You understood? See, cost from the local router is equal to the next router which gave you 18,000 plus your router and next router metric, that is 3,000.
So feasible distance is nothing
Is
but
the
the
total
distance.
distance.
Total distance. Okay. Got it.
Feasible distance, how did you calculate? That is very important. Don't miss anything that I am saying, anything in the presentation, because later you will struggle. Try to understand exactly what this says. I appreciate what you said is also correct. It's a total distance. But how did A know that it is the total distance? It knows the distance between A and B, and as advertisement it is getting 18,000. So it adds that 18,000 to this 3,000. That is how it knows the total distance. Do you agree?
So how this 3,000 came actually? I mean,
that it knows. See how 18,000
okay.
came.
Yes, they know already. Okay.
They know by using the bandwidth and the delay, they calculate. They use two things. One is bandwidth, other one is delay.
Yeah.
They take both the values on the link and they calculate. So for example, I have given 3,000, 18,000. It will be some numbers that is calculated based on the bandwidth and delay. Yeah. So that advertisement only gave partial metric, isn't it? If you don't get advertisement, if R1, RA don't get advertisement, how RA knows that it is 22,000? It will not know. 18 plus 3 is what? 3,000 is what? 18,000 plus 3,000 is 21. Okay, 21,000. How router A knows 21,000 without advertised distance? Not possible, isn't it?
Yes. Yes.
So router A still depends on neighbor to calculate its own metric. You agree?
Mm,
Router A depends on neighbor for its own metric calculation. Yes or no?
yes. Correct.
Yeah, that is why it is a distance vector protocol. RIP
Mm-hmm.
also same like this only, no?
Yeah.
Only the difference is RIP will advertise the total
Or
metric to router
yes.
A. Here, partial metric is advertised, isn't it? So
Yeah.
here, EIGRP on router A has got some role in calculating the metric. Whereas in RIP, it is fully dependent, learning by rumor.
Mm-hmm.
In RIP, we call it as learning by rumor. You know, whatever the other says, this guy
It
will
will.
believe. That is what learning by rumor.
Mm-hmm.
It won't use its own brain.
Mm-hmm.
Simply taking whatever the neighbor advertises.
Mm-hmm.
Okay, that is learning by rumor. Here, that's not the case. Here, partially metric is given by neighbor router,
Mm-hmm.
and A also uses its own calculated metric between A and B, which is 3,000.
Mm-hmm.
That is how it comes to know that the total metric is 21,000.
Oh,
Okay. Now, you understood this first 2 points, right? AD and
yeah.
FD.
Yeah. Yes.
Now, let me draw another diagram. Router A, router B, router C. And you see there's a network called 1.1.1.1. Now, A is receiving
Mm-hmm.
18,000 from router B.
Mm-hmm.
C is sending 15,000 for the same network.
Mm-hmm.
Now here, let's say it is 2K. Here, let's say 4K, 4,000. Now tell me, what is the FD via router B? Via
Okay.
router B,
20K.
20,000. What is the metric via router C? What is the FD?
19K.
19K. Now, both router B and router C can take you to 1.1.1.1, but which one you will take? You will take the lowest FD as the low cost. Did you agree on
Mm-hmm.
this? Do you agree on this? So this is the low cost, isn't it?
Yeah.
Lowest FD is the low cost. That lowest cost,
Mm-hmm.
that is given by
Mm-hmm.
router
Yeah.
C, isn't it? So this next hop path is what called as successor path. You understand successor? The path which is a winner, the path which is elected, the path which has got low cost, the path which has got low FD. FD is nothing
Total
but what?
distance. Yeah.
Total distance. The path which has
Mm-hmm.
got low FD is the elected path. What is the
Successor.
name for the elected path? Successor route. Successor path. So this path, because this is the lowest one, definitely there cannot be a loop.
Yeah.
If there will be a loop, there will be more cost. If there will be a loop, there will be more cost. So if you want to buy a land, go
Mm-hmm.
directly to the seller, there won't be more cost.
Mm-hmm.
But if there are a lot of people in the middle,
Yeah. Correct.
cost is going to increase. And then again comes to the owner. Oh, okay, I'm selling to five rupees, and he is selling my land to 8,000 rupees. Oh no, I'm not going to give now. I'll say I'll sell for 10,000. Okay, now owner changed his mind from 5,000. He has changed his mind to 10,000 because the broker itself is earning 3,000. Oh, no. So then when he says 10,000, the broker will say 15,000. And then the buyer will hear 15,000. And then the seller will come to know broker is selling for, oh, if broker is selling 15,000, if there is a customer to buy, then I don't want to be a fool. My land is 20,000. He increases because he did not want to be full. So likewise, in networking also, if there is a loop, I advertise 5, you calculate 5 plus maybe 2, 7, then you advertise to me 7, then I increase 2 to it, then it becomes 19, keeps increasing. So the low cost is the successor. It's a loop free path. Now this is the successor route. EIGRP will also maintain backup route to each destination. That is called as feasible successor. But it won't simply take this path as backup path. It will check whether it is qualified, whether it is loop free. If I choose this path, will there be a loop? If it will cause loop, then I should not take. So it will check whether it will cause loop or not. How it knows that there won't be a loop? How it knows that if I take this path, there will be a loop. If I don't take this path, there will be no loop. Or how it checks that?
Backup.
How the feasible successor. What is feasible successor? Backup path. How backup path is selected? This is the condition. The AD means no. This is the backup. If this is if you want this to be backup path, the AD. What is the value of AD here in our exam? 18. Is 18 less than the FD? What is the FD? Lowest FD? 19. If this is true,
Secondary path.
only then this is qualified to be the backup path. Yeah, secondary path. If in case, if this is 19,
No.
is AD less than the FD? No. Then this will not be considered. Even though the path is available, it won't be considered as a backup path. You will not see that path in the topology table. See, to be a qualified backup path, the advertised distance of the backup path should be less than the elected path, successor path, or FD of the successor value. Got it? So we call this as feasible condition. See, if you can get a path like this less than FD, then there won't be a loop. If loop is there, it will not be less. Sometimes if loop is not there also, it won't be less, but it won't take because it want to guarantee a loop free path. So sorry. We know what is successor. The lowest FD path is the successor. For the backup path, which is called feasible successor, the feasibility condition need to be met. What is feasibility condition? The advertised distance of the backup path must be less than the FD feasible distance of the successor route. Yeah, you understood this very well. So this is the magic that dual algorithm uses to find the best path and the backup path, and both the paths will be maintained in topology table. By default, only the best path will be installed into the routing table. Backup path will not be used. In another word, by default, unequal cost path will not be used. Is this equal cost path or unequal cost path? On top, Yeah,
Yes.
unequal cost. If metrics are different, it's unequal. All right, you understood this very, very well. Now, go through this picture and the table.
Yeah, can you explain?
Take your
Yeah,
time,
so there are three
understand
routers,
fully, and
A
then
and A,
explain
B,
me.
and C. Um, A is connected
Yes,
over
yes, please.
E0, I mean X0 of C, and B is connected over X1 of
Mhm.
C, and A is advertising to C about the destination 10.1.1.0 network, saying that its advertisement distance is 1000. And similarly, B is advertising to C about advertised distance 1500, which is the distance from B to 10.1.1.0 network, and from the local router C to A, the distance is 1000, and from local router C to B, the distance is 1000. Okay, and the feasible distance from C to feasible distance through from C to from C to reach to the destination, feasible distance is 2000, and from C to reach the destination network via B, feasible distance is 2500. Uh, since the feasible distance 2000 is less than 2500, so router C it will elect the lowest FD path here, which is 2000 through router A to reach the destination 10.1.1.0 via Ethernet 0. So it will be installed successor, yes. Mm.
We call it as successor. Okay. To be a qualified feasible successor, the
Yes,
advertised distance should be less than the successor. 1500
yes.
should be less than 2000. Yes, it is true. Because it is true, it is installed into the topology table. Okay, that's great. Now, very important topic you have already understood. That's the one place where many are not
Mm.
clear when we speak about EIGRP. Not much clear in this area, in this understanding of this page.
Okay. Yes.
Let's do one small lab. This is the topology that we were using previously to understand the protocol RIP. And now the same topology, I'm going to use it for EIGRP.
Mm-hmm.
Now, how do you remove the routing protocols that are running? See, there are two ways. One is you can go here and say no
Mm-hmm.
router RIP. This will remove the entire RIP from the router. Okay. You see, show
Yeah.
IP protocol is the command which will show you what all routing protocol currently running. There is no routing protocol. Got it? I removed RIP. Let me take you to the next router. Before removing, let me show you.
Mm.
Before removing, show IP protocol. You see, you have RIP.
Mm.
Now, let me show you the second way. The other way, see, if you have many routing protocol, instead of removing one by one by one by
Mm.
one,
Yeah.
in order to remove all the protocol in just one command, this is the command you
Mm.
need to type. Are you ready?
Yes.
No IP routing. If you type this,
Mm.
you are saying I don't want routing, which means it is going to immediately remove
Mm.
all the protocol, not only RIP. After that, you put routing
Mm.
again, IP routing.
Yeah.
Okay. Now, if you go and see no protocol, you see, you got it. Now again, let me show you in R3. Before removing, let me show you again. Show IP protocol. You have it. Now, no IP routing. So you don't need to know whether a RIP is running or EIG. Just put this command. All protocol will be removed and put this command back without no. Now use the same show IP protocol. Nothing. Yeah, gone. All right. Now there is no protocol now. We are going to enable EIGRP.
We have
Currently, what all networks we have in this router for?
which is loopback network 4.4.1. Sorry? Yes. Standard 34. Yes.
Next is standard 34. Yeah. Next is standard 34. Now, router EIGRP, you need to give an autonomous system number. Let's give a number, and you should use the same number on the other routers. And then, what are the networks? If you want to simply say 4, you can say 4.0.0.0. Or if you want to fully match with all these 32-bit, then you need to say 4.4.4.4 and then wildcard mask. What is this called? Wildcard mask. Wildcard mask is opposite to subnet mask. If your subnet mask is 255.255.255.255, then what will be the opposite? 0.0.0. What does this mean? This means that I want to run EIGRP only on the interface where IP address is 4.4.4.4. I repeat, if you will have like this, one interface with 4.4.4.4, one interface with 4.4.4.3, another interface with 4.4.4.2, 4.4.4.1. If you do not want to run EIGRP and all this, and if you want to run only on this, easy. Of course, subnetted. Let's say this is 24, this is 24, this is 24, this is also 24. Now, if I want to run EIGRP only on this, it is not possible in RIP. In EIGRP, I can say if any interface have got 4.4.4.4 only, means 0 means it should be 4 only, not 3 or 2 or 1. You understand? So it is easy to filter in EIGRP. Using wildcard mask, what do? You filter. You are saying, I don't want any other interface to run EIGRP. I want only that interface which has got this IP address. Did you understand?
Will that allow by a router?
This is needed only if you have many interface with same subnet with different IP. Yeah, it is. With anyway, you're going to have, you see, that's a good question. So let's say this one is also different. Or, okay, wait, let it be there. If it is 32, it will allow. Because they are unique, no? When you see 32, they are unique. It will allow. But in that, I want to only run EIGRP on this. So now, for the another network, I can simply say 10.0.0 also. because there is only one
No.
interface with 10. Yeah? Is there any other interface? No. I can simply say this. Or I could have also said what? 10.34.00.00.255.255, which we'll do in the next router. You see, show IP EIGRP interface. You see, EIGRP running on these two interface. Please pay attention. Next router is important. On the next router, show IP route.
3.0, no, 3.10.0, 10.34, 192, 168. 4 networks.
One minute. One is router EIGRP 100.
But that is 0, 0.
Network is 3.3.3.3. Mask is not mask. Wildcard mask is this. Network, see, if I say 10 also okay, 10.34 also okay. 10.34.0.0, I can say 0.0.255.255. See, immediately it has formed a neighbor with router 4. You see, it is up. Another interface is
Sir, one doubt, like for
192.168.0.0.
why we use
Now
0,
let's go and verify.
2.
Show IP EIGRP interfaces. Because I want to match
Okay.
these two. You no need to do that. No, simply I'm showing some examples.
0.0.0.255.
If you want to match 3 octet, then I will put what? Yeah. Next. Router 2. Show IP route. So the networks are router EIGRP 100, network 2.0. This is also okay. Network 10.0.0.0 also okay. You can also say like this 192.168.0.2, 0.0.0.0. You can also say exactly this IP address. You understood? Now one last router. One minute. Show IP route. Here again router EIGRP 100. Network 1000. Network 10.0.0.0. That's it. You see? If you check the routing table now, you see the routes.
Dual.
And you will be able to ping 4444. What is this D means? Very nice.
Yes.
So here also if you see D is given for EIGRP because dual algorithm is what EIGRP uses. Now there will be 3 tables as we see. One table is already here, best routes, having best routes. What is this table called? Routing table. Now if you want to see only the EIGRP route, then you type EIGRP. These are all the EIGRP routes. If you don't put EIGRP, it will show even the connected, isn't it? Now, we have seen EIGRP route. One table is over. Next table is show IP EIGRP interfaces. This will show interfaces. Okay. Show IP EIGRP neighbor will show you the neighbor table. How many neighbors router 2 should have? 2 neighbors. Let us check. Show IP EIGRP neighbor. There are 2 neighbors. One is router 1, the other one is router 3. This 0 means first neighbor. We've configured router 3 first. After that only we configured router 2 and then router 1. This is what I was talking about, smooth round trip time. For
Okay.
router 2 to talk to router 3, it takes 40 millisecond.
Mm. Mhm.
Now I told you every 15 seconds it will send a hello packet. You see, 13, 13,
Tell me.
12, 11,
Hello, packet.
10, again 14.
Mm.
Meaning after 10 it goes to 40,
Yeah.
which means every 5 seconds it is
Mm.
receiving the hello packet. It is receiving. It is
Mhm.
receiving a hello packet from the neighbor. If the neighbor don't send a hello packet, then it will
Yeah.
reach 0 and the neighbor will be
Mhm.
removed.
Yes.
If this goes 0, no, it will be removed from the neighbor table. Got it? Now,
Mhm.
show IP EIGRP topology is the topology table.
Mm.
See,
Yeah.
right now we have only feasible distance, means successors. There is
Mm.
no backup successor. See, in the topology, do you have any alternate route? No. No, there is only
After that.
one path, straight path. We don't have multiple paths. If you have multiple paths, then there are chances that you will have feasible successor. So in our coming classes, we will learn
Got it.
more about EIGRP, and then we will have a lab with other multiple paths.
Mhm.
Because you are now in CCNP, we will not be using
GNS3.
this
Okay. GNS3
tool.
can install in my system, right?
We'll use some advanced tool. We have GNS3. Okay.